to the cloud. Okay, welcome all. Do you hear me well? Okay, so my aim today is the past two seminars have been very abstract in the sense that these are the characteristics the system should have. What I'm trying to do here, and some of you will be familiar with that work, but is to translate that into actual data model UML diagrams. Bill asked me for UML diagrams last time. I was hoping for JSON-LD examples. I didn't quite get there in time, but I think we have enough material to cover. So there is some expected familiarity with the aims and some of the principles we did in the previous two seminars, but I'll try to go at it as I go along, and questions are welcome at any time. So I hope that's helpful. So yeah, so trying to get more formal. So what we said last time we had, and let me show, yes, thank you. Fragments are interpreted as, symbols in context are interpreted as concept representations. So interpreted is a key idea. Concept representations can be deemed equivalent. And so we get the concept as an equivalence class. And I said, maybe materialize, and I'm getting there, and we'll get into when I want to materialize this. Concept representations are named using a multiplicity of symbols. Name are in many-to-many representation relation with concepts. In the perspective, we can choose an unambiguous representative symbol for a concept. Statements reference entities. I didn't quite work that one in, but it remains true, and it's not the hugest deal. And concepts are separated by distinctions and joined by abstraction. And we have refinement of successive concept representations. So what does that look like as diagrams and the like? So first, the main problem, the reason it's taken me so long to write this, is dealing with identity. When we are dealing with mutable entities, what is an entity? What's a name? And up to a point, I've inherited the topic mapping perspective, where what we have is topics and everything's a topic. And that means if a topic has inner structure, every component of the structure is also a topic, because it's something that can be talked about, and it has an identity. Now, what are the identifiers for topics? Jack has been using UUID, for example, for topic identifiers, and I've been kind of between this, we can just make names on the fly perspective, which is valid, and the IPLD-inspired immutable identifiers for immutable entities. And I've tried to reconcile the two. So on the one hand, we want to give an identity. I shouldn't say a locator, but even immutable identities are a kind of locator to every entity at every level. If it's immutable data, we want stable identifiers, very much in the IPLD principle, though in theory, this is supposed to be an interoperability protocol. So I don't think we should be wedded to IPLD, even if we use it internally or not. What is important is the ability to create equivalence classes between identifiers, including immutable identifiers. But the idea of stable identifiers for immutable data, if you have immutable data, it should map to unambiguous, not necessarily unique, but unambiguous identifiers that will never change and will be shared among many systems in the ecosystem. So what this looks like is we have topics in general, and we have the immutable abstraction, which has an ID, which in IPLD is a SHA-256. And some data, and the data can be a string when we're speaking about symbols. It can be any structure, in which case, think of it as JSON, for example, or CBOR or protocol buff. It doesn't matter. We have data. And we have documents, which are blobs, where the structure is more opaque, if you will, but it's still an immutable. It has an identity and so on. Now, most of the time, we want to know what the symbol's about. If it's a structure, it's meaningless without a schema to interpret the structure. And if it's an JSON-LD context, which again, we may use, is an example of enriching a structure with a schema. Like if you have a database, you may have multiple tables with the same tuple in a certain row with totally different meanings in different tables or in different schemas in general. So we'd want to annotate these immutable structures with context. So there may be other schema languages that, again, imposing one schema language is not the aim, but it's very likely I'll use JSON-LD in a reference implementation, though a slightly tweaked one, probably JSON-LD star, because everything is nameable. Natural language strings are meaningless without a language identifier, similarly. So it's the same idea. You have annotated abstract concept, and we're saying, okay, we have symbols, for example, identifier URLs are pure symbols. And then you have language symbols, which have a ISO 639-2 tag as an annotation. And structure, you would have a schema. What I really mean here is the identifier of a schema or locator for a schema. And how do we get there? And I see there's something in the chat. Topic was empty. How is topic different from immutable? What members would you access through topic? Okay, topic is pretty much anything that can be talked about. And as such, it pretty much has to have at least one identifier. But here I'm trying to be flexible about the fact that there's many identifiers. So I left it empty for now. It's more about how it's in a way, it's like any, because anything's a topic, and we'll use it more in signatures of various functions. It'll come up as signature. Symbols usually come from documents, like language symbols especially, but not necessarily. Like I'm saying here, I'm following the web annotation standard. Like, for example, we can have we can refer to a fragment, which is a time slice in a video. That's not a symbol as such. I'm pushing it, but it's a kind of sub-document in a document. Here I'm saying we have extracts of documents, but in particular, we have language symbols, which are taken from a text document, or can be, for example, the transcription of a video document. And we also have the same notion of data fragments. Like, in a way, any tuple, you have some data source, and here data source, I'm saying it's a class, but think of it as a very, very abstract placeholder. It's something which you can give it a query and you'll get the structure. The data source implicitly has a schema, so you get a schema structure with schema annotation. And so a data fragment is saying, well, I did this query on this data source at that point in time, and I got that structure back. And that's a data fragment, which is an immutable, this thing happened. And what I'm trying to say is anything can be treated as immutables. Of course, not everything is immutable, but many things are immutable. And what I'm trying to say here also is things exist in context, and we'll try to broaden the notion of context. Fragment is the most obvious part of context. There's an origin for a piece of text. And in a way that document, for example, or that part of a conversation is part of a bigger conversation or a given subculture in which this document makes sense. We'll get to that. But right now, I'm just saying at a very narrow level, I'm defining what's a fragment. It's a piece of a document that makes sense in itself. Now, we have concept representations. And by the way, there's Timothy and Stephen are part of the Canonical Debate Lab. We spend a lot of time together discussing some of this. And I really want to acknowledge how much they have helped shape some of this. I'm not sure they agree with everything I'm saying, but they've had tremendous impact on what how these concepts have evolved through time, as well as Jack Park, of course. So concept representation, here I'm going to, again, underdefine it. We do want to get deeper into what's a concept representation, what's the structure of a concept. But here I'm going to keep it very vague. It's any structure because, again, different systems may define it differently. What's important is what can you do with it? What can you say about a concept representation? So it's a structure following a schema. It could be text. It could be a definition of a word as text, a dictionary entry. It's a concept representation. We're trying to define that term, and it's a concept representation. It could be a claim as text. Anyway, concept representations are not concepts. Concepts exist only in wetware in the mind of the emitter and the receiver of a language act, but they're concept proxies. So as such, they're topics. They're subject. The proper term is subject proxy and topic mapping. And as such, and this is something I really want to emphasize here, I used to think of names of concepts, and that's something on which I stumbled a lot. And I'm really stabilized on the notion that names or structures are standing for concepts. And as such, they're part of equivalence class of concepts. They're standing for, I should say, subject proxies here. They're standing for concepts. Now, in particular, among concept representations, there may be more. This is not meant to be exhaustive, but most cases, we have claims and definitions. So what's a claim and a definition? Oh, and of course, they form a DAG. That's important. And we did say we would use interpretation and distinction as key concepts in building our concept graph. And so those are claims. And note also they're immutable. We will, of course, concepts can evolve all the time, but concept representations are immutable. So what this is looking like is we have concept representations are one case of schema structures. Not all schema structures stand for a concept, though I'm not sure I can think of exceptions, to be honest. So maybe all schema structures are concepts or subject proxies, but not sure of that. But certainly some of them are meant to represent an idea. And some of those concept representations, as I said, are claims. They're statement, a claim is a statement that something may be true or false. Statement, something that may be accepted by someone as true or false, or maybe unknown, but potentially true or false, at least. So that's what a claim is. And here I say claim, I should be a bit more precise and say maybe something like standalone claim, but this is the terminology we're using and defining in the CDL. This would be a standalone claim. The idea is it's something that can be understood more or less on its own. But what happens most of the time is you have, and I should get into refinement, I forgot to weave that in, but we have fragments taken from documents and we're saying, I think, this is an interpretation, that this fragment means this claim or uses these definitions. And there's an arrow missing. A claim probably uses definitions, and that's the relationship between claims and definitions, this name. And now the definition is a bit underdefined, and I'm being a bit, the name is not part of the definition, and that's why there's no arrow here, because the claim should be about the definition name pair. In this claim, we're using this name to mean this definition. The definition is really, this is a description of a concept. And the description of the concept is not something you would agree or disagree to use it, but it's not something that you agree is true or false. It's a definition. You may or may not want to agree to use it. You may or may not want to use it for a given name, but the definition is not true or false. Is. Now, the definition doesn't have much inner structure because most of its structure is given by the relationship between definitions, which are distinction claims. Distinction is a kind of claim saying, well, this definition is more specific than that definition because of these distinguishing claims. Like this is true of the specific and not of other generic. So a distinction is really the key object, the key building block of definition. And that's a claim. It refers to definition, like concept, entity definitions, if you will. And here I'm cheating a bit because the distinguishers are claims with a free variable, I guess. And I did not get into modeling that in the scope of today. But there is the notion that some claims have free variables, and then we have to worry about variable unification. This is not in this part of the modelization. When I make a claim, am I making an assertion like in a semantic web sense? That's a perfectly valid question. Maybe, and I'll get to that. You may be just quoting the claim, as in semantic web sense quoting, or you may be asserting it. You make an assertion in the semantic web, you make an assertion when you assert a triple within a graph. The equivalent thing here is that you accept a claim in a perspective, and it's roughly isomorphic. But you can quote, you can just say this claim exists. Now, when we're speaking about mutability, of course, we can name mutable topics because topics, subjects, concepts change all the time. So we allow arbitrary identifiers. So those are just symbols. And that includes explicitly URN, URL, author identifiers, language symbols, query from an arbitrary data source. And that means they could be ambiguous. And we'll get into the notion of how to get to a non-ambiguous naming scheme later. But right now, let's just worry about the mutable aspect. And when we speak of mutability, there's two ways to deal with it. It's, okay, here's an identifier, give me this mutable thing as it is now. Give me a snapshot. That's document locators. And the other way to do it is with event sourcing. And I much prefer event sourcing, but of course, document locators are easier to implement, and that's what everybody's doing, and that's reality. So we need to be able to translate between the two. So what we're looking at is we have transient event source, which just you can subscribe to a topic ID, and I'm leaving that a bit vague. There's a symbol, which again might be ambiguous, but let's assume here it is not. You just, and so assume it's an unambiguous topic ID, you'll get a stream of events about that topic. If you're lucky, your event source has a memory. It's not transient. You can ask, okay, give me the events from this date to this date, or even better, the events from this date to this date about that topic, and you'll get a more restricted stream of event. And what's important that there's a history, and that makes it possible for a topic event source to say, okay, I can compile this stream of events from here to there, or I should not have had a stream, but a list of events into, okay, this is the corresponding structure snapshot that you would get out of that. And so I can ask, okay, what is the snapshot that I get at a time and point? Now you could, in theory, have a topic event store that is built on a transient event source that could only give you the current snapshot. Did not represent it, but it also makes sense. What is important really is that it must be possible to, if you have an arbitrary document source like a web server, you give it a locator and it gives you, okay, here's a bunch of bytes. So you should have a proxy should know enough about the document, the bunch of bytes, the blob, to say, well, actually, this is this structure with this schema, and I can actually say that these changes happened. So you could construct, in theory, a proxy that would say, well, from this time to this time, you had these events, you had this snapshot, and between them, here is a reconstructed set of events. And maybe the set of events will be particularly stupid, such as the document disappeared in this snapshot and reappeared in this new snapshot, and we don't know what happened in between. And that's fine. The point is to be able to think of mutable topics as being expressed as events as much as possible, because it makes thinking about mutability easier in many ways. So what's a perspective? I spoke of perspective, the equivalent of a graph. So we have claims and definitions and basically a lot of things, and we want to say, I'm accepting some of those claims. And that's what a perspective is. It's saying those claims are accepted. They're not just quoted. They're not just, this claim exists, has been made by someone somewhere. It's, from my perspective, this claim makes sense. And so each concept representation has a history of accepted, if you're talking within a perspective, replacement proposals. A replacement is a claim that this concept representation is more appropriate than this one. It's more precise, it's more this, it's more that. Often, and this is not so clear in the diagram, in the coming diagram, this is a better representation of this concept for this name. It's a better interpretation, for example, of a fragment. But it could be, this is more up to date. And here we get into the event sourcing part. This entity has changed, so here's a better representation of its current state. That's a replacement. It could be, this is a more precise description. Like, for example, if I have a claim that John gave a ball to Mary, well, it was, by the way, it happened at this time, and it was, here's the, when we say John, we actually mean this person, citizen of this country with this SIN number, so we know exactly who we're talking about, and the ball weighed 0.2 kilograms, and anything that can make the statement more precise is a replacement. So, and some of those may be accepted in a perspective. Replacements don't have to exist within a perspective. But of course, within a perspective, some of them will be accepted. So for any concept representation, you have a tree of this can be replaced with that. And I say it's a tree because there may be uncertainty. Oh, it could be this one or that one. Now, in general, replacements form a general graph. It doesn't even have to be a cyclic, because some people may say A is better than B, B is better than A. But the idea of a perspective is that because we have the notion of acceptance, we can add constraints. Okay, sorry, I missed quite a few questions, sorry. Stephen, do you feel I answered about dynamic content on websites with my notion of proxies? That was the point.
No, the question was based on that fact. I mean, yes, I get how it changes the websites over time, but how do you deal with dynamic content? Literally, let's say a clock on a website.
Right. Well, you would, the idea is the proxy would take snapshots of the document source at whatever interval suits it. And
so it would be a change of that dynamic content whenever it looks at it, essentially.
Yeah.
Okay.
Now, of course, it's also perfectly valid for the proxy to say, I'm aware that there's a clock, so let me erase that part from the dynamic representation, right? That's also valid. But here, I'm assuming the proxy knows what it's proxying, so it can make guesses about that. But that's the whole point. The whole point is you have something that is dynamic, you don't know, you don't control, you can't go back in time in general for a document source. So the point of the proxy is to make it event-like. And that means
but so it means you might need site-specific proxies that get obsolete over time, etc.
Yep.
Okay.
And so that was one question. And the other question was, Bill has to go. Okay. Okay. So where was I? Sorry. I was saying that the point of perspective is I can form the replacements to form a tree. I can force the replacements to form a tree because I'm taking a subset of replacements. And when there's a forking, because forking happens, I can say, oh, maybe A is better than B, and maybe C is better than B, and I'm not sure. Or I accept that both are valid hypothesis and or from different people, and I'm on the social side, so there's not one truth. Then you can have the tree nature of the replacements, and then you'd have a fork points, which is materialized. Now, this is especially important when you're trying to be more precise about concept representation, and you're saying there's this refinement and that refinement, and we're not sure which. So that creates a fork point, and I would materialize that fork point. And I'm saying locally question mark. I think locally because in outside of perspective, in the grand federated view of everything, it's a generalized graph. It may not be a tree. So the fork points, there's in a way too many fork points to materialize them all the time. Whereas within the perspective, we have a more restricted view of the replacements. So it is conceivable to replace the fork points. Fork points may also correspond to a valid abstraction. Whoops, I had too much text here. This is a conversation we had about when the replacement corresponds to a name that has many interpretations. And this is the interpretation relation. It's possible that many interpretations are abstractions of one another. Here's the abstract interpretation, but maybe the person meant that more specifically. And in some cases, the abstraction makes sense. And then, it's a valid abstraction. It has meaning in and of itself. And sometimes the abstraction does not make sense. The example we give often is Paris is nice. Do we mean Paris, the city? Which city? Paris, Texas, Paris, France, or do we mean Paris a person like Paris Hilton or Paris the Greek hero? There's no sensible abstraction that covers all those cases. That's homonymy. Whereas if I say climate change, and then I could include or exclude ocean acidification as part of what I mean by climate change. When I say climate change will cause untold damage to sustainability of the human race. This sentence could be true with either the precise or broad definition of climate change that includes or excludes ocean acidification. So what's important is when you have these replacements, the leaves of the replacement is, okay, these are currently valid concepts in that perspective. And of course, the valid abstraction, the fork points that are deemed valid in their own right. Was there another thing? I suspect there was. Okay, I should be less verbose in a slide. I was working on this at the last second. So in a perspective, I can ask, was this concept accepted, and get a Boolean, and really it should be a generalized truth, but let's just go, it should include social truths, which I'll define another day, but let's just start with Booleans. And I can ask, okay, what's the history of list of all the replacements that apply both in the past and the future? Maybe I could have two functions there to that concept. And hence, is it accepted and is it valid? That's another function. Is it either valid abstraction, a valid fork point, or a tree leaf within that perspective? Latest, that means give me either the valid fork point, either the fork point or the tail concept, the leaf concept. All the naming I should have removed from that slide. It goes in the next slide. And so the fork point is says there's an abstraction and alternatives. I should say that it belongs to a perspective. This did not belong in that slide, sorry. Replacement is the, basically it's materializes a link between two concept representations. And of course, replacement itself is a claim. Oops, is there a slide missing? No, this looks like. Okay, there is a slide missing. Is there an error? Yes, there's an error. Brilliant, sorry. I was working on this. No class language symbol. Okay. Concept equivalence. Let's see if that helps. Nope. Yes, okay. Oh, God. Apologies. Okay, so this is much better. So we have an explicit equivalence relation, as I said. It generates a perspective local, again, materialized equivalence classes. And within the perspective, we can enforce coherence of those equivalence classes with the distinctions. No two equivalent concepts should have a distinction. And replacements, if I'm replacing, well, it depends on the kind of replacement, but I'm probably kicking the old concept from the equivalence class, because the whole point of making a replacement is saying this is better than that. So I'll come back to naming diversity. So we have the equivalence class saying here are many concept representations, and that means I can create locally. Again, I will only materialize within a perspective. I won't materialize globally. Here's the history of a given local concept proxy. So basically, I can say, suppose I have a local concept proxy, a materialized equivalence class. We'll see how to get to them. I'll say, okay, what's the history of that, all the equivalences in the equivalence class? And we can ask, there's many concept representations, and we can say, okay, for a given schema, we can pick, this is my preferred, and this draws on the replacement. Like sometimes a replacement is just more precise and doesn't kick the original out of the equivalence class. But we'll say, okay, this is our favorite representation for that schema, or the preferred name for that language. There might be many in some cases, but I think the whole point of having a perspective is that we pick a favorite name and a favorite representation, even if there can be many. And that's the whole point of having an equivalence class. And what we have really, how we build those preferred is we have the notion of preferred name, which again, not obvious on the diagram. I need to work a bit on the diagram. Associates either a symbol with a representation or, with a local concept proxy, but it could be with a representation, it wouldn't matter. We can have replacement between preferred names because they're claims. I can say, oh no, now I prefer this name. And so there would be, and here I think we could enforce that there's not a tree, but a unique preferred name and a unique preferred representation. Again, within a perspective, we can have constraints on accepted replacements to enforce these things. And we'll have the preferred representation would be basically the replacement representation, but a non-binding, non-distinct replacement representation. So we can ask, given a preferred name, what is the local concept proxy for that one? Or given a preferred concept representation, what is the latest one? And maybe I could also get, I should have added a function to get the local concept proxy from a concept representation. And if I have, and this is really important, if I have a topic identifier, again, there's no guarantee that there's not multiple topics. I have a topic identifier, it could be ambiguous. I could have many local concept proxies, and then I'd have to rely on the distinctions to know which one do I mean. But it would, I could use, the whole point is to use the history of the distinctions to say, okay, if I meant this one, then I probably mean this one now. And the idea is to latch on as soon as you can to a preferred symbol. So this one, when you follow the history, it's more, you'll have the history of replacements and you'll see the fork points, and each fork point will be justified by a replacement of which you can identify the distinction. This is not all clear in the diagram. I'm still working on that, on those diagrams. But this is where I'm at, 44, in terms of translating all this to UML. There was a lot of hesitation about, do I accept arbitrary topic IDs? Yes, it's doable because I can resolve topic ID ambiguity through distinctions. A lot of things that are materializations of, here are all the possible either equivalent concepts, concept representation, or the non-equivalent ones using the fork points and the distinctions. This allows me to, being able to do that within a perspective allows me to have clear materialization. So this is where I'm at, trying to translate that to database tables at this point, still working on this. Questions or comments at this point? None? Probably bad news. Tim, you're smiling. Stephen also.
Well, you know my opinion, right? I have 1,000 questions about this. For me, it's too fast, too abstract, too little concrete instances that actually show how these relations work in practice. So rather than asking 1,000 questions, I'm just following the high-level ideas you're presenting, some of which we already discussed at great length, right?
Yes, yes, yes. Again, we're having these conversations a lot within the CDL. This is my way to summarize the state of things to hopefully a broader audience. Marie, anything, Marie or Jack?
Yeah, I just agree that some examples would help. It just goes ahead of the need for some of these distinctions.
Okay. Obviously, I'm showing what I have at this point, but what I'm trying to do is to have, for a long time, I was avoiding data representation because I was very concerned about identifiers. And whenever I would start to write tables, I'd have identifier issues. I have, okay, let me look for this work, not this one, not this one. Where is that window? Okay. Let me just share my screen in general. I want not this one, not this one. Sorry, I'm being a bit the hybrid syntax. Oh yeah, this was an attempt to create a syntax for this. It's not what I want. There's a presentation I made for Society Library where I got a bit more into this. This was an example of me making claims and fragments as pure JSON LD. Well, pure turtle, but with the JSON LD translation. I think I have the, where do I have? Yeah, here's the JSON LD translation, but I think it's easier to read as turtle. I had claim, support, claim occurrence. This was really getting into the structure. So this would be what I now call a fragment. I'm changing my vocabulary. And something I want to point in here, I'm saying it's asserted. So that was, that's the epistemic status of a claim in a given context. So here I'm working within the perspective, which is not obvious because perspectives are not materialized at this point.
You do know you're not showing your screen right now.
No, I did not. I thought I was. Apologies. Is this? Thank you. So I was saying, so this is an example of something I did with for Society Library as an example, purely as a proof of concept, where I wrote a claim and argument structure as JSON LD or as RDF. And here's something that's a claim occurrence, which is the equivalent of what would be a fragment. And here, the fragment is asserted, which is something that would only make sense within a perspective. So I would probably have a layer above. So what I would want is to be able to say, this is the this is the content of the claim. This here is the content of the claim, and here it happens to be text. And it doesn't matter, as I said, text is a perfectly valid concept description. here it would be hopefully a standalone claim in CDL parlance. And I'm saying, well, I think this claim occurred in this fragment of text. Here they're identical, but this could have been a more standalone rephrase. And I would expect a refinement to say, well, let's rephrase this to be clearer about what we mean by this. And something we could do is to have a formal version, which would be another claim structure, which hopefully would be said to say the same thing. So this would be an equivalence relation saying this is a rephrasing in a different schema where I would say make that into a frame structure. This is not a frame structure. I think, did I have frame structures in there? Text quote, claim statements. No, I only had text claims in this version. I did have a version where I was working on text structure a bit. But anyway, I'm not looking for it now. What I'm trying to say is, yeah, this only illustrates the relationship between text fragment and, in a way, text, but simple claim structures. What would be interesting is to show it on an actual piece of text where we show the evolution of ideas. The problem is I've been a bit constrained creating examples because I didn't have the notation for it. One thing I've been working on, among other things, and I wanted this to be my next seminar, but it will probably be the one after that at this point, is to, let me find this, have a good markup structure. And I did say, I don't believe this will be markup ultimately because I want multiple layers of annotation, but it's still useful for example creation to have markup and to say this bit of text corresponds to this concept. Here's the structure of the concept and so on. And I'm close to that, having a good markup so I can build examples. But as I said, I was struggling with the data structure. What is absolutely wrong about this JSON LD I showed, or this turtle I showed, is that the identity of the claims and structures is a local identifier. And ideally, I would want to be able to say, well, let's say that this is equivalent to this IPLD identifier, so it becomes globally reusable. Now that is just an equivalence it's the same as operator in RDF, right? It's the identifier equivalence. And it would be pretty much local because precisely I'm using a local identifier. So it makes sense. Something that I did not put in my slides is the other key complex operator is translation, saying this identifier for this claim in this perspective, well, actually, this is my name for this concept, and doing the translations between names as they are used in another perspective and names as they're used in my perspective. So that's the, but again, on the one hand, it's easy to do this as accepted claims of translation. The really hard part is how to make that into a useful distributed structure. I've been thinking a lot about a kind of distributed hash table or even Bloom filters saying, okay, this identifier is used in these perspectives and that event sources. I did not make explicit the link between perspectives and event sources. I expect most perspectives to build on event sources. And so I could say, well, these identifiers are used here. So where would I look for these equivalences? between names used in this perspective and names used in that perspective. I don't think I'm answering your question. Sorry, Murray. It's where, as I said, work in progress. And the examples are still in need of formalization, let's put it this way. Because I'm building the data structure now, so I can write down the examples as data.
I have a question in terms of process here, because I mean, at the pace you are going now, you're gonna be forever defining data structure and never having actual data. Like when do you think you have a structure you're happy with, like an MVP structure, if you will, that you can actually start creating instances and actually running queries on it, etc.?
I'm actually pretty hopeful at this point. There's a lot of, in a way, I'm aware that this looks like UML diagrams I've done before. In another way, there's a lot of things I had to tweak to make this closer to something resembling a data structure I think I can put in a table. The main problem was identity, as I said. And I'm comfortable now that I have a better idea of how to handle identity. So I think it should be not days, but probably close to a week or two. I should be able to translate those UML diagrams into database tables. For a long time, I was like, I'm not there. The difference today is with the current UML diagrams, I'm more confident I'm close to a database structure, even if I understand it's not apparent from the outside. There's been a lot of changes to identity in there. But point taken. Anything else? Or should we're at the hour? Okay, thank you, everybody. I'll try to have concrete data and examples for the next seminar. See you soon.
Don't forget to have a nice weekend. See you.
Thank you. Goodbye.
Have a good weekend.